Ladies and gentlemen, good evening. My name is Marchel Manullang, and I'm delighted to be here with you today to discuss the analysis and optimization of spring mass temper system, particularly in the context of military vehicle application. So for the introduction, before we delve into specific, I would like to encourage all of us to maintain a conscious and analytical mindset while addressing this complex problem. Moreover, let us also keep our faith and hope in God, as it is He who guides us through both our intellectual pursuit and personal endeavor. Okay. And for the point of discussion, the topic that I gave to be covered is the first one is intention, initial thinking, utilization, instruction sets, statistic, result. That means is the recommendation about the spring mass system, and the last one is closing. All right, for the intention. What the primary intention? So, the primary intention of this presentation is to explore the methodology for evaluating different spring mass chamber system and to identify the most suitable configuration for military vehicles. We will begin with the theoretical framework, proceed to the numerical analysis, and conclude with a comprehensive recommendation based on the results. Like I said before, we must hope in God. With the help of our Lord Christ and Day 5 method, I hope the resulting solution will be satisfactory. All right, we continue to initial thinking. To begin with, let us consider the fundamental challenge. Military vehicles operate under extremely demanding conditions, encountering rough terrains that impart significant forces on the structure. Spring mass temper system is critical in mitigating these forces, ensuring the stability and integrity of both the vehicle and its payload. Our goal is to determine which configuration of spring constant and damping coefficient provides the optimal performance in terms of minimizing displacement. And for the idealization, to simplify our analysis without sacrificing accuracy, we adopt the following assumption and idealization. The first one is planar system. We assume that the system behave planarly, adhering to Hooke's law, and Newton is second law. The external force. The external force acting on the system is periodic and sinusoidal, representing rough terrain impacts. And for the critical damping, we consider damping close to the critical value to avoid excessive oscillation. And initial condition, the both displacement and velocity are zero, and the factors such as temperature and humidity are ignored for the analysis, and small displacement are assumed to be small enough for linear approximation to hold. And for the instruction sets, further explanation regarding the analysis results will continue and be directly demonstrated in MATLAB. Right, we now proceed to the detailed step involved in our analysis, beginning with the known variables and moving through the computational methodology to derive the unknown. Okay, the first one is define parameter, right? So here we have the mass of a trailer with satellite is 1,800 in kilogram, and the external force function for roof terrain here. The function of t is equal to 200 times sinus of 4 times t. And for the shock specification, we have three of them, where the first one is air coaster with the damping coefficient is 220 and the critical damping is 100. And cloud riders with a damping coefficient is 59 and the critical damping is 1050. And the last one is extreme shocks with the damping coefficient is 170 and the critical damping is 1110. And for the time parameters, we know that the end time in seconds is 10, with the time step is 0.01 seconds, with the time factor is 0, with the time step until the time end is 10 seconds. And here for the mathematical formulation, like here the differential equation solver using Euler methods and displacement and critical damping value, where we're going to use a simple equation like 2 times square root of mass time damping coefficient with the initial condition is with the initial condition is for the initial displacement and initial velocity, the both of them is 0. And we're gonna do a simulation, we're gonna get the displacement result for the shock here. And then we're gonna plot the result. So we're gonna plotting the displacement, create a plot to compare the displacement over time for each shock absorber, and the plot will show how the system responds to the external force for its configuration. And then we're gonna go to simulated uh, and we get the plot and the maximum displacement for its shock absorber. So in here we gonna get the recommended shock absorber is the extreme shocks because it has a maximum displacement is equal to 0.03999 meter. So we can see the plot that the extreme shock has a minimum displacement here. So after trough analysis and comparison, the recommended shock absorber for the military vehicle will be the one that minimizes the displacement the most effectively. The conclusion ensure that the fusion system provides optimal performance in mitigating the impact of roof terrains, thereby enhancing the stability and integrity of the vehicle. Right. And for the statistic, yeah, like what I said before, the displacement versus time plots for each shock absorber will show how the system responds to the external forces. And the comparison will help identify which shock absorber minimizes the displacement the most, indicating better performance. And here the results. Air coaster with the maximum displacement 0.0781 meter. The cloud rider's maximum displacement equal to 0.0468 meter, and the last one, that the recommendation of the shock absorber is extreme shock with the maximum displacement is equal to 0.0399 meter. And yeah, we are done for the day. So in conclusion, this systematic approach combines theoretical principles with numerical analysis to derive meaningful insight into the performance of different spring mass damper systems. By adhering to the outlined methodology to ensure a robust and reliable recommendation for the most suitable configuration for military application. So thank you for your attention, and I welcome any question of or discussion on this topic. Thank you.